There's two big differences in our next example. Number one is obviously the application, duh. But second part is the construction. Remember, the other one was doing a count. This time we are doing some type of manipulation with the list. There's also a third one behind the scenes, and that's we're using cond instead of the if-else. This could be easily replaced with the if-else scenario, but still I wanted to show you that version as well. The overall setup is the same. Remember, one of the first items is to understand what we're doing with the application. And in this application, it says right in the comment there, we're going to return a list of M1 to MJ and then L1 to LK, where M is M1 from MK and then L is, I should have just had you read that. But anyway, so we're going to end up putting just two lists together, but they keep their respective places in order. And that's why it's called append. So what are we going to do? Remember, the overall game plan we got to figure out is how are we going to do this. So we're going to have to add one of the list to the new list and pass the rest and add that next one to the, and then notice bit by bit by giving it a list that slowly shrinks, we're adding the new item to the larger list. And that's exactly what's happening. Instead of the +1, we're using cons this time because cons is meant to, well, add or append items to a list. So there's a lot of little differences here and there, but in reality the construction is just about the same. So let's look at our overall setup for our if and else case. So our null case or our base case and our else case. So first you'll see that if it's null, looking at the list M, then we return everything we had in L. And you're actually going to see that here in our example. Else, we're going to construct the first character in M and then append it, calling that recursive function call, with the rest of our M and then our original L list. So you're thinking, wait a minute, I'm going to be passing L the whole entire time. The answer is yeah. And you'll actually see that's being highlighted right now. But each time I'm passing actually one list I'm using that as a case of, hey, this is what the list will look like. So let's go through the call, the condition, and the value return. So you're going to start seeing things disappear again. So if I'm going to append A, B, C, D, and 1, 2, 3, by the way, I made them off count. I made one count of 4 and count of 3 just so you understand what happens if we hit that null. So we check our first condition. Is M equal to null? The answer is obviously no. So we're going to cons A, that's the first character in the M list, and then we're going to append it, calling recursively, B, C, D, there's that change of the list, one element off now, with the original L list. And again, I'm going to keep going up. Next call is the append BCD, solving for 1, 2, 3, and this time I'm going to cons pen. So I'm going all the way up until finally at the very end where we get to, well, there's null, so I'm going to return the rest of the L list. Now here's where the trick comes in. That then becomes, that's where all the X's are coming in here. I'm consing D to the list of 1, 2, 3, and then C, and then B, and then A. That's how everything works out with overall, again, going from our call and value stack, once we get to our base case, collapsing from there, and then physically doing the work from there.